So when we speak about organic chemistry, we are talking about the chemistry of organic molecules. So each and every time we speak about organic chemistry, you must understand that that is the chemistry of organic molecules. It's a chemistry of organic molecules. Chemistry of organic molecules. Molecules. So one thing that you need to understand with regards to now drawing the structural formulas, I think you are all familiar. So to those who are not familiar, let's say they say draw the structural formula of butane. So butane is it's an alkene that has 4 carbon atoms. So you'll draw it as follows. You draw 4 C's that represents carbons, and then you draw all hydrogens around that. Draw hydrogen, or rather you write hydrogen, 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 hydrogen. You also write another hydrogen. Also write another hydrogen. Also write another hydrogen here. H as well as H. So one thing that you need to understand is that this is going to be what? That is going to be structural formula of butane. This will be the structural formula of what? Of butane. Now one thing that you need to understand is that butane, it falls under alkanes. What is an alkane? Alkane are saturated hydrocarbons with single covalent bonds between carbon atom. And one thing that you must never forget is that the alkanes, the name ending, it will be A hyphen A. It's like /A. So we know that we are working with an alkane, just like that. So if you watch that video, actually, you'll understand that we also have isomers. I explained what is an isomers. So a definition of an isomer, these are compounds with the same molecular formula but different structural formula. We call it an isomer. So an isomer, it must have the same molecular formula. Same molecular formula. Molecular formula, but different structural formula. So I even made same molecular formula but different structural formula. But different structural formula. So that is an isomer. So I even made on the previous video, I even drew the difference part of isomers. And I said there are 3 different types of isomers. We have chain isomers, we have positional isomers, I think, as well as functional isomers. The last one, I'm not sure the last one, but it's there on the previous video. So one thing that you need to understand is that it's a must that you must know basics of alkanes. Now we are moving to alkenes. So the difference between alkenes, and alkynes is that alkenes, these are single covalent bonds between carbon atoms. Alkenes, the one that we are doing now. Okay, before that, any question? Any question?
No, sir.
Okay. So one thing that you need to understand is that alkenes, they have what we call a double bond. Always. Double bond between carbon atoms. So the moment you see a double bond between carbon atoms, you must understand that that is an alkene. And then one thing that you need to understand is that an alkene, the first alkene, I think it will be ethene. It will be ethene. So ethene, we regard it as the first alkene, simply because of you must have a double bond. There's no methene, it's ethene. Ethene, it's an alkene, not an alkane. And one thing that you must also remember is that alkanes, the name ending of an alkene, name ending it's E. Name ending is very important that you must know it. So we are coming from alkanes, the name ending it's -A. So then, since this one we are dealing with an alkene, the name ending it will be -E. So this basically means to say for you to be able to see that you are working with an alkene, you must have at least one double bond. You get to see that. So the first alkene that you'll have, it's ethene. You know why? Because it has 2 carbon atoms. And then just because of its ethene, it has 2 carbon atoms. And it being ethene, it means to say it must have a double bond. So that will be our double bond. Do you all see? And then after that's our double bond, you'll write another hydrogen, hydrogen here. Another hydrogen, another hydrogen. You'll also write another hydrogen right there, as well as another one right there. So this is the structural formula of ethene. To those who don't know, this is the structural formula of ethene. If they say draw the structural formula of ethene, you must draw this one. Structural. Okay, I don't know why this thing is. Okay, let me. I just want to make sure that my handwriting is a bit good. Structural formula. It's much better. Structural formula of ethene. So that is ethene. Ne? It must have 2 double bond. So to those who are naming it, someone can say 1 or 2. Someone can say also 1 or 2. You're not gonna be wrong. So ethene, we know that ethene it has a what? It has a double bond. A double bond. Any question? Any question? So if there's no question, then we are proceeding. So if they ask you to say, what is an alkene? Alkenes, you must know that they are the unsaturated hydrocarbons. So now angry we are dealing with alkenes. You must write somewhere to say alkenes. By now, you must understand that alkenes are what? So alkenes are saturated hydrocarbons, but alkenes are what? Unsaturated hydrocarbons. This is unsaturated saturated hydrocarbon. Hydrocarbon. So to those who don't know, when we speak about a hydrocarbon, these are compounds or molecules that contain what? Hydrogen. That contain hydrogen. That contains hydrogen. Hydrogen as well as what? As carbon atoms. As well as carbon. So that's what we mean when we speak about the hydrocarbon. So alkenes, we regard them as unsaturated hydrocarbon. So the alkenes are unsaturated hydrocarbon with covalent double bond between carbon atom. And here I told you to say alkenes are saturated hydrocarbon with single covalent bonds between carbon atom. So when we speak about an alkene, these are what? These are unsaturated hydrocarbons. You can write it. Unsaturated. Okay, let me do like this. I think it will be wise if I do like this. Unsaturated hydrocarbon. Unsaturated. I'm gonna try to type it down. So when we speak about alkenes, these are unsaturated hydrocarbon with double covalent bonds. So we're gonna have what? Double covalent bond between carbon atoms. Covalent, double covalent. double covalent bond between carbon atom, covalent bond between carbon atom. So one thing that you must know, alkanes single covalent bond between carbon atom, alkenes double covalent bond between carbon atoms, and then alkynes triple covalent bond between carbon atoms. So those are some of the things that you must know. And you remember that I told you that the homologous series or the formula that denotes all alkanes is CnH2n plus 2. But with regards to alkenes, the homologous series or homologous series or their formula that best denotes all alkenes. The formula that best denotes all alkenes is what? It's going to be CnH2n. Let me show you what do I mean by this. So let's go back to the structural formula of Eth. So that structural formula of ethene, we know that it has two carbons as well as a double bond. Then, so here it will be hydrogen, there it will be hydrogen, here it will be hydrogen, here it will be hydrogen. Remember, you'll also be asked to do what? To write the molecular formula as well as the condensed structural formula. But before that, I want us to use this formula since this is the formula that best denotes all what? All alkenes. So the formula is CnH2n. And then you'll say C. Don't forget, this N is simply represent the number of carbon atoms in this case. So how many carbon atoms do you have in ethene? There are 2. So it will be C2. And then that will be H. You're having 2 from the formula. Since now you know that ethene has 2 carbon atoms, you'll say open bracket, then you write 2. So look at that. That will be what? That will be C2, H, and then you say 2 times 2, that will be 4. So this basically means to say, now as you are having, let me show you. Now as you're having what? As you're having C2H4, it simply means to say also here, when you go to this structural formula, you must have 2 carbons because this 2 simply means to say you're having 2 carbons here as well as 4 hydrogens right there. So when you're going to the structural formula, you can see you're having 2 carbons, which is 1, 2, and then also 4 hydrogens. So where are those 4 hydrogens? It's 1, 2, 3, 4. Correct. So it basically means to say this formula is correct, and that is the formula or the homologous series that best denotes what? All the what? The alkenes. Don't forget, alkanes CnH2n plus 2. Alkenes CnH2n, just like that. Any question? Any question?
No, sir.
Okay. Now, if there's no question, you can continue. And then still on the same concept, now if I can ask you what is going to be the molecular formula of ethene. Molecular formula. So it will be as follows. Molecular formula. So remember that the molecular formula, it will be what? It will be this C2H4. This C2H4, it represents what we call our molecular formula. And for you not to make mistakes, remember you get it from this homologous series or this formula that best denotes all alkenes. And then one thing that you'll also come across is what we mean when we speak about what a condensed structural formula. So with regards to the condensed structural formula, it will be a bit different in this sense. So this will be the condensed structural formula. Condensed structural formula. So the condensed structural formula of ethene, it will be what? Remember that structural formula, remember of ethene, I wrote something like this. Then we're having double bond. Hydrogen right here. Hydrogen right there. Hydrogen right there, as well as hydrogen right there. So for you to get the condensed structural formula, you take this part. You see this part? That is CH2. Because we're having what? We're having what? We're having one carbon atom together with two hydrogens. So it will be CH2. That is the first part, right? Take into consideration that now you're working with an alkene. You must show your what? Your double bond. Double bond. And then you're gonna also take also this part, which is gonna be another second part of CH2. So it will be CH2 as well. It will be CH2, then you write CH2. So this basically means to say this part, which is CH2, double bond CH2, it represents what? It represents the condensed structural formula of ethene, because this molecule or this organic compound is what we call ethene. Taking into consideration that when we speak about an ethene, you must understand that an ethene it's an unsaturated hydrocarbon with double covalent bond between carbon atoms. As long as it has a double covalent bond, then it makes it to be ethene. Take into consideration again that the name ending is "-ene". Why? Because "-ene" is the name ending that best denotes all alkenes. So those are some of the things that you must understand. Not forgetting that on the general equation, coming back to what I've just recently explained, CnH2n. Since this is the homologous series of all the formula, you must understand that n represents the whole number of carbon atoms. Always. N represent, let me just write it for the sake of you guys. N represent what? The whole number. Whole number. I'm just going to explain what do I mean when I speak about the whole number. N represent the whole number. The whole number of what? Of carbon atoms. Whole number of carbon atoms. So what do I mean when I speak about the whole number? So a whole number, it's a number that doesn't have commas. So the likes of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up until positive infinity. That's what we mean about the whole number. This basically means to say you can't get it. That's why when we write our molecular formula of ethene, it's C2H4. And get if it's ethene, you can't get it like this. You can't get it like this. Let me show you. You can't get it like this. C1, 2, maybe H5. You know, this 1, 2, it's a decimal. So when you speak about the whole number, it must be a number on its own. And then that number, which is a whole number, it represents the number of carbon atoms, just like that. That's why here normally I say it represents the number of carbon atoms. You check there are 1, 2. At the end of the day, it will be what? If you go back, it will be a C2, isn't like here. Isn't like here, C2 and then H8. H represents hydrogens. Don't forget that. Ne? So one thing that you also must know is that natural gas contains small quantity of ethene. Ne? And then most of the alkenes used in industry are obtained through cracking of petroleums. So okay, let me write this. I want to explain it. Cracking. So as we'll be dealing with organic reactions organic reactions. The reason I'm teaching you these basics is because of where we are going. We'll be dealing with the likes of types of reactions in chemistry: hydrogenation, halogenation, esterification, alcohols, etc., etc. You must understand that what most alkanes are used in industry, or most alkenes, so to say, that are used in industry are obtained through cracking of petroleum. So the other term for cracking is thermal cracking. So when you speak about thermal or cracking, we're speaking about you breaking an organic reaction, of which you will see at the later stage that when you speak about organic reactions, some types of reactions, they happen through a catalyst. It can be PT, which is platinum. It can be PD, which is palladium. It can be Ni, which is nickel. So you need to understand that in chemistry, all the reactions, they happen under a suitable catalyst. And then if I can say, define what is a catalyst, you must understand that the catalyst is a substance that speed up the rate of a chemical reaction. So you must remember this term, catalyst. You'll see it at the later stage, catalyst. I will explain it at the later stage, but a mere definition or a simple definition of a catalyst is a substance that speed up the rate of a chemical reaction. Let me make an example. If you like doing experiments like myself, let's say you are buying a Coke. After you are buying a Coke, you pour it inside a glass. After pouring it inside the glass, take eno or salt or sugar, pour it inside that Coke. Let's make an example whereby you are taking Coke, you are pouring it inside the glass, and then you are taking eno, the eno that you know, the one that you drink when you are having maybe fever or something. You take eno, you pour it inside the Coke. What's going to happen is that you'll see a chemical reaction. That Coke is going to react. You know why? It's because of you have added eno. So you adding eno, it simply means to say you have added the catalyst. Why? Because it's a substance that speeds up the rate of a chemical reaction. That's why after you pour that eno inside a Coke, it might start to split, or you'll see bubbles overflowing, etc., etc. Because of at that very same moment that acts as a catalyst. So you'll actually see when now in supporting my statement, the last statement of me saying natural gas contains a small quantity of ethene. Most of alkenes are used in industry are obtained through cracking of petroleum. You must understand that the diesel that you know for a car, the petrol, which is petroleum, mainly for us to have a petrol. These people who did chemical engineering, they're the ones who normally calculate or come with these formulas of us at the end of the day having petrol. So one thing that you need to understand, you'll come across the term thermal, which is cracking. So thermal, which is cracking, is kind of like me giving you an alkane, and then a long alkane, maybe let's say an alkane that has 10 carbon atoms. Though now we are dealing with alkenes, I want to explain the term cracking. Or since we are in alkenes, let me explain. Let's say you are having octene. Yeah, let me make an example based on alkenes since we're doing alkenes. So octene, it's an alkene that has 8 carbon atoms. Since it has 8 carbon atoms, if I were to draw it, I will draw it like this. I want to explain something. 1, 2, 3, 4, 5, 6, 7, 8. As long as it's octene, it simply means to say that double bond, it will be on the first carbon atom. There is a reason why I'm saying that. So you can label it and say 1, 2, 3, 4, 5, 6, 7, 8. This is not octane, guys. It's octene. You know why? We are working with alkenes. And don't forget that the name ending of alkenes, it's in. That's why I'm saying octene here, because it's an alkene. So if that's saying draw a structural formula of octene, it's a must that your double bond should be on the first carbon atom because it's octene. Remember, octene in, it's an alkene, and then it must have a double bond. And then, since they didn't tell us that where is the double bond situated, here they wanted us to draw a structural formula of octene. It means to say it must be on the first, between the first and the second carbon atom. If they said draw the structural formula of 3-octene, in this case, it simply means to say, if they were to say draw the structural formula of 3-octene, I was going to draw that double bond between the third carbon atom and the fourth carbon atom. It will be like that. So the reason why I'm not doing that for now, I'm saying let's draw the structural formula of octene is because of, if you're drawing the structural formula of octene, they didn't tell you where to position the double bond. So hence it must be on the first carbon atom, just like that. You get to see that. And then you now know that here it will be hydrogen. Even this one, it will be hydrogen. This one, it will be a single bond. And then when you count, remember each and every carbon, it should be having at least four bonds. So that is 1, 2, 3, 4. We are now safe. And then with regards to carbon number 2, we are already having two bonds. And then we're going to have the third one. And then the other one, you can write it here. That serves as hydrogen at the bottom. But to someone who will prefer it to also write it up here, up here, as in like here, hydrogen, you're still gonna be correct. There are many ways to kill a cat. I hope you are listening and I hope you are learning. So let's write it there. And then single bond, we know that now we continue to be hydrogen, hydrogen, hydrogen. There's a reason why I chose octet, because this is an alkene that has 8 carbon atoms in the main chain, right? So it's too long. So I just choose the long alkene simply because I want to explain this term of creaking. You will see this more when you're dealing with organic reactions. And then this is hydrogen, we all know. There's going to be another hydrogen here. That's going to be another hydrogen. Don't forget that here, there must be a single bond here. And then one carbon atom should be at least attached to 4 bonds. Just like that. You put hydrogen, you also put hydrogen. So this is the structural formula of octet. So coming back to what I was saying with regards to thermal cracking, this is an alkene. I can break it. When you break it, you will get different types of structures, of which breaking a long chain, a long carbon chain, we can change it into writing it using shorter chains. And then in that regard, we call that thermal or cracking, because we are just breaking the main chain, right? So those are some of the things that you must understand. And then continuing, let's say they want us to draw the structural formula of propene, because for propane from alkanes, you now know how to draw the structural formula if you watched that video. So now let's say they want you to draw the structural formula of propene. I'm just giving you basics for the sake of those people who might be struggling to understand this. So propene, remember, it's an alkene, and as long as it's an alkene, it must have "-ine" as the name ending here. And then, Angry, you know from alkenes that an alkene that has 3 carbon atoms, we call it propane, because simply means to say the name ending in "-ane" and then it's an alkane. So in this case, it's going to be propene because the name ending is "-ine." But you must understand that it must have what? It's going to be an alkene that has 3 carbon atoms, because an alkene that has 3 carbon atoms, we call it propene. Do you get to see that? And then, if they didn't tell you the position of a double bond, you'll write it like this. Double bond here. And then this will be your hydrogen. This will be your hydrogen. And then here you can decide to write it here on top or at the bottom of that carbon atom. It doesn't matter. We're also having this hydrogen. We're also having this hydrogen. Hydrogen right there. 1, 2, 3, 4. So here we don't have a hydrogen. Let me write it using a different color, but though I'm going to erase it. You see the green one? Don't put a hydrogen here, because I told you that one carbon atom, it must have 4 bonds. So already there, we're already having 4 bonds. Let me show you. It's 2, it's 1, 2, and then it's 3, it's 4. So we're already having 4 bonds. And then since we are now having 4 bonds, if you decide to write another bond, they're no longer going to be 4, they're going to be 5, of which is wrong. I hope you are learning. So that is the tricky part that one needs to know. And then with regards to that, this will be a structural formula of someone who has numbered it like this: 1, 2, 3. So this is propene. But there is another person who can not draw this propene like this. Someone will also draw propene like that. There are many ways to draw this. Someone will draw it like this. For the mere fact that you know that it's propene, it must have what? It must have 3 carbon atoms. So someone will position the double bond here. And then our hydrogen, as well as another hydrogen here. So someone can draw it like that. Let me show you. Someone can draw it like this. Hydrogen. 1, 2, 3, 4. Cool. Hydrogen there. Also having another hydrogen. Also having another hydrogen. So don't put, let me show you here. Don't put another hydrogen here, because you'll be wrong. Because now if you count those bonds, they're no longer 4. They're no longer 4. Look at that. It's 1, it's 2, it's 3, it's 4, 5. Do you get to see? So that's wrong. That's very wrong. Any question? So with regards to this, this will be for someone who label it like this: 1, 2, 3. They're still gonna be correct because that will serve as a what? That will serve as a structural formula for propene. Any question? And then remember, alkenes, they follow a certain trend when you are naming them, as well as also alkenes. So here we'll be speaking about naming of alkenes. Naming of what? Of alkenes. Because you don't just decide to choose the way you name it. There is a certain procedure that we follow when we are naming all organic compounds. Like in this case, we are working with alkenes. Do you get to see that? So one thing that you must understand is that the longest chain or the longest straight carbon chain in which the double bond occurs is chosen. Number 1, you must choose the longest chain. When you are naming alkenes, you must choose the longest chain. If you don't say choose the longest chain, you can just say the longest carbon chain in which the double bond occurs is chosen. So it simply means to say, when I'm saying the longest carbon chain in which the double bond occurs is chosen, you must always name, because they can give you an exam a structural formula of an alkene, and then they want you to name it. Sorry, in that regard, when you are naming an alkene, you must understand that the first point, the longest straight carbon chain in which the double bond occurs is chosen. So you always number an alkene closest to the double bond. That's why here, actually, look at this. My double bond is closer to the first carbon atom, just like that. Do you get to see? Because if yeah, here comes a good question. Let me just read these numbers. I want to show you something. If you can put your double bond here, there's something important that I want to explain. If you can put your double bond here, sharp, we are still correct. That is the structural formula of propene. But if you can number it like this, as in like 1, 2, 3, then you might be wrong. You know why? Because in this case, look at this. The double bond is situated on carbon number 2, of which you need to rearrange your naming. Why? Because point number 1, they're saying the longest straight carbon chain in which the double bond occurs is chosen. So look at this one. If you are numbering it like this: 1, or 2, or 3, can you see that the double bond is situated on carbon number 2? Hence, the naming of alkenes tells us that the longest straight carbon chain in which the double bond occurs is chosen. So it means to say you name or number closest to the double bond. So look at in this case, it's 1, it's 2, it's 3. Do you see that my double bond is now situated on carbon number 1 when I'm naming it from right to left? Look at the other one, which is wrong. This one, when you name it like this, it's gonna be 1. Look at this. The double bond is situated on carbon number 2, of which is wrong if you're gonna name it like this. The proper way to naming it, it's gonna be 1, it's gonna be 2, it's gonna be 3. But don't misquote me. It doesn't matter whether you put your double bond on the right hand side, as in like here, on the right hand side. It doesn't matter again whether you put your double bond here on the left hand side. The only thing that is very important, profound, and that one that you need to always adhere to or stick to is the rules of naming of alkenes. The first rules of naming of alkenes, I'm gonna keep on emphasizing this. You always choose the longest straight carbon chain in which the double bond occurs. This simply means to say, whenever you are given an alkene, because remember, they might not even tell you to say this is an alkene. How will you know that that is an alkene? You know that, oh, this is an alkene. As long as it has a double bond, it's an alkene. Perfect. After knowing that, if now you're going to name that organic compound, you must go on that alkene, numbering it closest to the double bond, because you always first by choosing the longest carbon chain, and then you number it closest to the double bond. So one thing that you need to understand that you must never forget is that the root name is formed by changing the extension A in the name of the corresponding parent alkane to E. Because remember, I told you that whenever you are talking about ama alkene, the name ending it will be what? Ama alkene, the name ending it will be hyphen in. to tell us that now you're working with a what? With an alkene. And then at the end of the day, you understand that, oh, since this is a name ending of "-ine", it's an alkene, and then alkene, it has a double bond. Those are some of the things that you must know. Are you with me?
Yes,
And then,
sir.
yes. And then after choosing the longest chain, number 2, the second point that you must know. Ne? In the case of ethene and propene, there's only one possible position for the double bond. So in the case of ethene and propene, there's only one possible position for the double bond. What do I mean by that? I've explained ethene, and I even explained to say, you know what, the first ethene that we're gonna have. Yeah, oh, I wanted to say the first alkene that we're gonna have is gonna be ethene. Ethene. And get it like this. It simply means to say here there's no way you can choose where to put the double bond, because based on point number 2 that I'm reading or that I'm telling you, we all know that in the case of ethene and propene, there's only one position for the double bond. So I get this one is a structural formula of ethene. And then if that's a structural formula of ethene, you understand that in